A typical use for app storage is for preferences or settings. Some things to consider for preferences or settings is what will the default or initial values be, where will the values be stored, and when will the values be stored. In a previous example, when the username key had no value, the input field appeared as empty. This would lead us to think that the username key had the value of an empty string. However, if we try to access a key that doesn't have a value yet and display the value, it actually returns null. The input field displays null as an empty value, not the string of null. So what is null? Let's look at this from the perspective of a variable. So variables can contain two types of data, primitive values and references to objects. Primitive values are typically directly stored in the variable and have a small fixed size, like booleans or numbers. Strings, arrays, and objects do not have a fixed length and can be large. Instead of being stored directly in the variable, a memory address reference is stored in the variable, which points to where the data is really stored. JavaScript is unique in that the primitive types like boolean and number are also objects. As of ES6, JavaScript has 6 primitive types. We have boolean, number, string, symbol, null, and undefined. For variables that reference objects, which is all variables in JavaScript, it's possible that it may not be referencing anything at all. When a variable doesn't reference anything, it has the value null. Null is a way to indicate that a variable doesn't have a value, it is explicitly nothing. So if a variable doesn't have a value, then it's the value null by default. Well, no, not in JavaScript. In JavaScript, variables which haven't been assigned a value have the value of undefined by default. Undefined means that a value hasn't been assigned a value. You can actually assign undefined to a value and also check if a variable is undefined. In JavaScript, null must be assigned. It's not automatic. So wrapping up this little conversation on null versus undefined. So most languages support null and don't have any concept of undefined. JavaScript uses undefined by default. So it assigns any unassigned variables are undefined. However, it also supports null. JavaScript will not automatically assign anything as null. This has to be done programmatically. Getting back to Ionic Storage and setting initial values, Ionic Storage sets and returns null if a value hasn't been set. So we must check for null in that scenario. When you get the value from storage, the only way that you will know if it has not been overridden by the user is if its value is null. So the logic for a preference or setting will therefore be get the value from storage. If that value is null, meaning that no value has been set before, then let's set the property to some default value. Else, if it has a value, then set the property to whatever the value was that came from storage. Having injected the storage module in the constructor, we can call the get method of the storage object, which returns a promise with the value of the key. With the returned key value, we are able to test for null. If the value is null, then we assign a default value, else we assign the value of that key. The async await syntax makes the code for initializing values simpler to read. The process is the same as before, using our promises syntax, but the syntax with async await is a lot easier to read and reads more like synchronous code. Instead of storing keys individually, you may want to group them into objects. For example, you may want all of the preferences in one object. As an example, you could store the preferences in the following object. So our preferences object is going to store a sound level with a notification value and a username. This approach doesn't use storage keys for each preference, just a single key for the entire object. We can use standard object notation to access each of the object's properties. To set initial values, you will first have to test for a null object from storage. If the test returns null, then you could set default values to each property in the object. If the value coming back from storage is not null, then you can assign the object to your preferences or settings variable. In this example, we have a single key for all of the app settings called app settings. These values are then used to set a local variable called settings. If we're using an object, you should first assign a value to each property of the object and then assign that object to storage with a key using the storage.set method. The problem with the previous approaches is that if a value is used in multiple locations in the app, then every time it is read from storage, you would need to assign an initial or default value. If you want to change those values, you need to change them in multiple locations, and that is a lot of code. One solution to this is to ensure that the default values are set when the application first runs before the rest of the app runs. With this approach, we will need to attempt to access every value. If it is null, you will need to give it a value and then store it immediately before the rest of the app attempts to access it. The best location to run code at startup is in the app component. A method can be created called, say, initialize app, which is then called in the constructor. As this is done in the app component, it will only be done once at startup. You will need to ensure the storage module is imported into the app-component.ts file and injected into its constructor. If you have separate keys for your settings, then you will need to load and set each one individually if they are null. In this example, we await the test on the username key for a null value, and if required, await the setting of the value for username before proceeding on to the password. This will make sure the defaults have been set before moving on to loading the rest of the application. In every app, there are two possibilities for storing changes to settings. So we could either do it at every time a component value changes, or when the user presses some save button. The first option is safe in that the change happens immediately and the user doesn't need to press the save button. The second approach could be also considered safe if the user makes a lot of changes but realizes they want to revert to the old settings and can cancel instead of saving. It is a design choice that you will need to make. The example of saving the first name when the add contact button is pressed is an example of a save button approach. Preferences are often changed when a component value changes. This means that you will need to add change event handlers for every component. The event handler will need to set the value of the key in storage for that component value. However, a shortcut would be to have only one event handler, which all components refer to, which also saves all of the values. This is less efficient, but it is less code.